Okay, hello everyone. Welcome back to another one of our sessions in our forum cybersecurity program. In this session, we're fortunate that we have Fortinet, who's going to give a presentation about business continuity strategies for securing industrial control systems. And we have three speakers for you in this session. There you go. There you go. We're going to have Rick Peters, who's the CISO of Operational Technology for North America. Carlos Sanchez, who's the Director of Operational Technology in the Central Region. And Chris Blauvelt, who's Director of Operational Technology in the Eastern Region. Okay, I look forward to listening to hear what you guys have to say.
Thank you very much, Sid, and welcome everyone, and appreciate the opportunity to share today on a subject that myself, Chris, and Carlos are pretty passionate about, and that is really protecting industrial control systems and all the effort that's going into raising the bar, right, to protecting operational technology across a variety of surfaces. You know, we're gonna break the subject down into some pieces over the next 45 minutes, so hopefully illuminate some new points, maybe confirm some others that you already believe. And that's really important because the top here, we're really talking about consequence engineering, understanding what's happening out there. What do we need to be thinking about, you know, from consideration of the adversarial playbook and their ability to leverage historical tradecraft to target what we know in operational technology is often the encountering of legacy hardware and software, not uncommon to find OS that's 20 years old. So we have to be able to determine how to move forward smartly to manage new technologies as they emerge in combination with, of course, all of what is already out there. And it really starts to turn our attention away from just understanding what the perimeter looks like, but thinking about access and the kinds of things that the cyber adversary would accomplish against us to be disruptive. So as we start to think about those concerns, we have to think about some of what has been showcased over the last couple of quarters. Many are aware of attacks on a broader scale that have affected both commercial and government. So from time of access to reconnaissance to elevated privilege, we have to be more proactive in protecting our environments. So we'll think about that so we ultimately can neutralize that adversary, that individual or individuals who are trying to execute a campaign to disrupt business and ultimately to provide a cost that can be very difficult to recover from. You know, this illustration is really about trying to reflect that commodity really is indeed the most interesting aspect of what's going on out there today. We understand the changes that have happened through that term of most widely known as convergence, where we've connected historically separate or even air-gapped systems. And I think what this illustrates again is what is unique. What are the unique components and aspects of operational technology? So when you start to consider devices like PLCs and RTUs, all those components that we don't typically think about in the IT space, yet here we are facing how to manage those and all of the industrial interface. And then that combined with connecting that into the business world. So really a proliferation of applications and a number of connected devices, right, that expand the perimeter. And we have to manage and protect that perimeter. So I would advocate that we need to apply a proportional amount of attention or investment to directing cybersecurity as a managed way to address the expanded attack surface. Because the consequence, of course, of a failure to do so means obviously we're losing dollars, but more important, I think we're putting our workforce, our customers at risk. Obviously, brand reputation is top of mind, but too often today we find ourselves becoming way too familiar with the vernacular that is what's happening out there on the front lines. So whether it's a structured attack by nation state or something that's coerced by just pure greed, there's a whole lot happening out there. This timeline illustrates way too many successes that have made headlines. And too often the attack scenarios, ransomware being top of mind, elicits familiarity with terms like WannaCry, NotPetya, Locker Gaga. These are terms that maybe historically you might not have thought about, but boy, they're making headlines today because they, again, illustrate the propensity of an entity to not just gain access, but then to seek to disrupt what we're trying to accomplish. That's very important as a critical piece of infrastructure, delivering services, whether it's energy, manufacturing, transportation, even into the building automation spaces. There's a whole lot table stakes wise that we have to care about. And the losses are proportionally high, as you can see from this simple illustration, ranging from the tens of millions to even over $1 billion. So, across the spectrum of what they're trying to accomplish, we recognize that cheap and dirty is probably the way most adversaries want to get on to the target today. So phishing attacks, yeah, they're still top of mind. They're a great way to get on. And extortion might appear to be the most important thing that's being accomplished. However, what's behind the lines probably is more along the lines of industrial espionage. The real desire to steal that which is important. Call it the crown jewels, your intellectual property, your trade secrets, however you characterize those, you can be fairly certain that as part of the campaign, it really is designed about profiting to a whole new level. And even further right, you might get to what we characterize as industrial sabotage, where now you're trying to ruin the reputation at a whole nother level. From the subtle to the kinetic, we can certainly do a whole lot of damage. And I think that's important to keep that in your minds, because as we go through and take a peek at what's happening out there to address and neutralize the threats, and we can start to realize, there's some promise out there to move forward, to mature how we're protecting our assets and continue to do due diligence, right? As I talked about being proportional on our approach. Recent events certainly amplified the value of what's going on there. And I think supply chain has become, tip of the tongue for many. Everyone wants to understand, who can I trust? How can I trust? Really understanding the dependence, right, on a variety of forcing functions that are a part of our business. And when we start to turn our attention to understanding how we are managing our assets, our physical enterprise, our hardware and software infrastructure that comprises our entire environment, from the cloud all the way to the plant floor, we realize quickly we got a whole lot of things that are competing for executive attention. What do we look at first? The left there, the too many vendors, really gets around a disparate array of point solutions where you may have adopted a sequence of products that don't work together. They don't communicate. And so the natural tendency then is to introduce latency into understanding what's happening in my environment. And of course, in OT, that's a killer. Optimizing our ability to understand what's happening behaviorally, very important in event management. Speed of response has to be proportional and correlate to what's happening. So I need to go from detection to quarantine to analysis, response, and recovery. And I need to do that at the speed of business. Otherwise, I'm at risk. So we have to think about efficiency in that space. And the last point that bears inspection as well is what's happening with our workforce. A lot of conversations today are centering around the supply line of people, talent. Is that really the issue? I would offer as well, it's investing in your present workforce to make sure that you can pivot and have your workforce become an asset instead of a liability. Having that a part of the total equation so that as you seek to be more resilient in the cybersecurity space, you're thinking about what it means to turn and pivot from a place we've been before to where we're going to be in the future. No better example of that than early in 2020, when, of course, the pandemic, which hit us globally, and certainly OT got no free pass, was confronted with, how do we work from home? How do we manage this new way of doing business? So lots going on there that's certainly opportunistic for the adversary, but I would say, as we've applied lessons learned, equally opportunistic as we move forward to achieve what that new normal will look like. I would offer that one way to start to peel it back is to understand that there's a logical way to examine the problem area. I like to consider a way forward based on an established or recognized framework. This is an illustration that mimics the NIST cybersecurity framework, and it allows us to then start to break down the problem, to recognize that there's a logical way to treat and think 24/7. Think about it as a continuous trust assessment. So from identification to protection, detection, response, and recovery, that's a continuous process. It never stops. It continues to confront us. And of course, our adversaries don't stand still. We understand the lack of ethics and their willingness to be aggressive in their space. So we have to be equally committed to understanding that and being able to mitigate that risk at speed. I like the fact that this model very much mimics Fortinet's approach to trying to protect operational technology by using more of an ecosystem way to think about the problem. It addresses these key OT principles, safe continuous operations, but then starts to help us understand important elements like transparency, i.e. designing security in without adding latency. The ability to scale a solution, because we know that OT system owners aren't fond of change. So whatever we're doing needs to take them on a journey to get to a destination of long-standing protection, sustainability. And then the other piece, equally important, is the speed of the process that happens. Your solutions and what you're designing in really need to operate at speeds that go well beyond much of what's out there today. And I think that's a huge edge as well when we think about the problem space. So I'd ask you to think about that. And then a final way to think about the problem space is to adapt that NIST framework. And then think about the Purdue reference architecture, because that's a model many are familiar with in the operational technology space. A great way to take an examination of the environment from the point of where IT and OT converge, we'll call that DMZ, all the way down to the plant floor, and to realize that there's an intelligent way to think about how to design security in at every layer. So as we start to talk about ideas like zero trust network access, security-driven networking, dynamic cloud security, you then can start to layer in the ideas below that says, well, first we got to start with visibility, because we can't protect what we can't see. We have to understand the need to have a firewall with switching and controls in place. Thinking about control, then talking about working your way into a strategy that employs segmentation and role-based access. You see these kinds of tokens in there now, and that allows us to address these at each layer, distinct layer of the architecture, so that what we're doing in effect is establishing zones of control. Very, very important, right? Because if I cannot contain the adversary, they're on the run and I'm chasing, and that's causing me lost downtime, which of course amplifies the loss cost-wise very quickly. And then as you get closer to the plant floor, understanding behaviors, and we're going to explore that today in a lot more depth, understanding it at almost a primitive layer, right? Because the communications in OT are unique and different. So traffic visibility, understanding the accesses, and being able to detect behaviors at the speed of business, equally and very, very important. At this point, I'm going to pass the baton over to Chris Blauvelt, who's going to take you on a journey with protecting data in motion. Chris. You're on mute, Chris.
There we go. Thank you, Rick. So I get a lot of questions about how do I implement some of these protections? How do I segment my network so that I can control devices that have become compromised? And so what I'm going to do today is talk about a few ways that we can architect the network so that you can implement these controls, but also do this in a way that allows you to follow some of the many regulations that we often find our industries covered by. If you're in electric power generation, NIST, NERC, CIP is an obvious one. If you're in the federal space, you might be having to comply with FIPS. And if you're in Europe or overseas, you might be having to comply with NIS. So we can go to the next slide. One of the things that Fortinet does is it allows you to use a multifunctional device. So I think a lot of people have seen the devices in the image on the top left, electromechanical devices that did a single thing on a single part of the control system. They would often have to be chained or paralleled so that you could achieve full protection. Now you can buy a device similar to what's on the right that does all of these functions in a single device plus more, and it's usually easier to integrate. We do the same thing, and so when I'm talking about using a firewall as a device for controlling your network, I'm talking about all of these functions, including some additional ones like antivirus, and virtual patching. So if you can go to the next slide. Having a device that's designed for a rugged environment is extremely important. All of our rugged appliances are designed for IEC 61850-3, and they support a variety of protocols that you'll often find in use in your operational environment. PRP, we're starting to see a lot of consolidation into using PTP instead of the various other time protocols such as NTP or maybe iRig. Having that dedicated ASIC for accelerating your high bandwidth, low latency applications, one or the other or sometimes both, is extremely important because a lot of our applications are latency sensitive. Being able to create secure tunnels back to a control center, whether that control center is on site or at some remote consolidated location, is also important to be able to do while not overburdening the CPU of the device. Next slide. And so we also offer something called application control. And what does that mean? Essentially, it's deep packet inspection of over 40 different industrial control protocols. What this allows us to do is first identify what protocols, what services are on my network. You might have an IED out there that has a service that's operating, that's available, that might be in use that you're not aware of. And so one of the things that's a best practice is to disable those services that aren't in use on that device and on your network. And so as you begin to deny protocols that you don't want operating on your network, what we start to see is essentially being able to whitelist the protocols that I want to see used. And there are a variety that are out there, Modbus being the most common, but a lot more advanced protocols than what Modbus offers, of course. Now that you've disabled the unused services on your IEDs, you can start to go into finer grained detail. If you have a device that only needs read functionality, you can only give it read functionality of a particular protocol. This is a very powerful way to limit what a device is able to do instead of all of a particular protocol or none of a particular protocol. And also another use case that we see for this application control is simply denying all industrial control protocols between interfaces. This allows you to separate your OT DMZ. Maybe you have a non-industrial control protocol like PyData or something like that you're using to get data up into your enterprise environment. So you need that connection, but you don't want industrial control protocols to be able to send commands or things like that from your enterprise environment. Next slide. And so some of the architectures that we commonly see are, here's something that you might see in a substation. So you have your process level or your level 0 if you're using the Purdue model. That's really where the action happens, right? That's your contact closures, your analog sensors, things of that nature. And that gets rolled up into your IEDs, your PLCs, your protection relays, things of that nature. And so you're going to have some real-time protocol that those devices are using to communicate with each other. Some systems still use hardwired contacts, things of that nature. And then from a data perspective, data and control, that rolls up into your station level or your level 2 of the Purdue model, where you would have an HMI or some kind of communications device like a remote terminal unit. That rolls up into your control center, whether it's on-site or off-site, if you have consolidated remote operation control paradigm. And so what you need is you need access control. You need to be able to know what's on your network. You need that communications to be secure so that you don't have people sending commands. You don't have people using CVEs that are known to be vulnerable on your devices. And ensuring that through segmentation and visibility, you have that system integrity and you can keep that change management. You go to the next slide. And so here's a common segmentation architecture that I often see in use. You have some kind of communications processor or RTU used to segment the networks. Say port 1 is the top of this device, port 2 is the bottom of this device, and then you query the devices on the bottom, your relays, PLCs, DCS, etc., and then you combine that information up into your historians and your local control planes. That data also gets sent off to your common control center. Number of disadvantages with this. One, it's not a firewall, and so it's not designed for the same level of protection as a firewall. It doesn't receive updates as frequently, and even if it did, you can't really apply those updates in a zero downtime fashion. Your HMI and your historian have unrestricted, unmonitored access to that communications processor. So if one of them becomes compromised, it can be very difficult to do something about it in a timely fashion. Next slide. And so a proposed architecture using a firewall, using that application control, allows you to break these devices or these zones down into what you commonly see as zones in a firewall. So level 3 remains the same. It connects into the firewall. It does not have access to level 1 directly. If it wants that access, then it has to go through level 2. Level 2, using software-defined networking, some call it microsegmentation, allows you to separate the historian and the HMI from the RTU and monitor that traffic through the firewall. So you get the visibility and you get the control should one of them become compromised. The RTU in this example is the only device that is able to talk down to level 1. So it has the same role as it did before, but you are managing that through an always-on security device that can receive live updates and doesn't require any downtime to fix vulnerabilities. Next slide. And so here's an example. Your control center wants to send a command to one of the devices in your level 1 zone. So it will send a command to the RTU, similar to what it would do before. The firewall, since you apply the security policies, allows you to send that command to the RTU. Next slide. Then the RTU is what accesses the PLC, DCS, or any of the devices in your level 1, and sends that command down to the intended device. And so one of these use cases for the RTU is to consolidate commands for the command center. Maybe the command center sends a command and that requires multiple commands sent to multiple devices. It's still able to accommodate that role, but you're able to monitor what it's doing in real time. You can go to the next slide. And so in the same architecture, the HMI, even though it is on the same switch as the RTU, through software-defined networking, is not allowed to talk directly to it. The reason you would want to do this is because the HMI becomes compromised. You want to be able to isolate that device immediately with means other than simply unplugging it from the network. A common strategy, but I think we can all agree is not time sensitive. And so the next slide shows how the RTU, the data goes back to the RTU. On the next slide, the RTU is following the same route that it did before. It's querying that device on behalf of the HMI. And so then you can apply your read-write policies to your historian. So your historian, you might want it to go through the RTU. You might want it to talk directly to the devices on your level 1. That only ever needs read access. So what you can do is you can deny messages that send commands. So your write commands in some protocols or different commands for different protocols. But I think you get the idea. Next slide. And so some other use cases that we see are using these FortiGates, these firewalls for comm relays or for endpoints on your microwave systems. We are often asked to submit a proposal for a microwave site in some of these industries. They're asking for a router, they're asking for a firewall, asking for a switch, and sometimes they're confused that we only come back with one device. The reason for that is that it's that multifunctional device. So it can serve as that router, as that firewall. And in some models, they have enough port density that can also serve as that switch to allow you to get the control that you need while also monitoring the communications and keeping those logs. Next slide. So another use case is remote access. You can go to the next slide. So back to our original architecture, oftentimes these RTUs, engineers can log into them, but they're often locally managed accounts, sometimes integrate LDAP. I have not seen one that integrates multi-factor authentication. So to go to the next slide. What we can do is we can use the authenticator and tokens to be able to provide centralized managed accounts through Microsoft AD, Radius, LDAP, etc. But also provide that second factor of authentication. So if you have an engineer at your level 3 zone that needs to directly communicate with a device, they can still do so, but in a authenticated way. And so what that allows them to do is log in, have a secure login, but also document that a login was made. And then you know the commands, you know what was sent through that firewall because you're monitoring the protocols. You can also use this for role-based access to make management of those accounts easier. Next slide. And so another use case that we see is secure SD-WAN being used to improve communication reliability. A couple of the reasons you want to do this is that it's application aware. And so we can use the awareness of that application to help steer, to help define your own SLAs for, say, a control protocol that might have different requirements than PyData or synchrophasers or things of that nature. If you have a failover connection, it might be bandwidth constricted. So it allows you to only allow those critical control protocols to pass over that link instead of trying to send all your traffic across it, which might make the link become unusable. And it automatically chooses those best links. And another part of this that's important is that it does not require cloud management. So if you have and need air-gapped networks, you can still use this SD-WAN because the intelligence is built onto the box, it's not built into the cloud. And so here's an example that uses static line OPGW. You could have fiber or something of that nature that goes from one site to another. It has microwave or LTE as a backup. Your LTE or VSAT connection would be bandwidth constricted in this case. And so in this particular instance, you could also limit the application that can travel over that backup link. Next slide. Here's an example that uses a tertiary backup. So you might have MPLS that you want for reliability reasons, security reasons. We can give you an alternate path. When you're using the MPLS and the alternate path, you can use both at the same time. If they're both up, you can maximize your bandwidth. You can also use forward error correction. So essentially you send all the packets over both links and you deduplicate them at the other end to make sure that the packets got there. In this example, we have an LTE or VSAT connection that's your tertiary backup that allows you to maintain that control as we discussed before.
Thanks, Chris. At this point, I think we're ready to move over to the application of cloud capabilities, and Carlos Sanchez is ready.
Thank you, Rick. Yeah, when we are talking business continuity strategies, I mean, for secure industrial control systems, we have to take under consideration cloud. And there are some common themes in our chat here. We have heard about consolidation, security of critical assets, remote access, and protecting data in motion. And top of mind when applying security treatments to our critical infrastructures are always the same. They all center around visibility, visibility of traffic and devices, control to appropriately steer traffic and segment set traffic, and awareness of devices, users, transactions, and such. No different when we're adding virtual structures to our business continuity strategy. I mean, right now we're facing new challenges as our production and our workforce is decentralized. Government regulation not only applies to operations and production, but also there are some new challenges in our industry, like reducing carbon footprint and that digital transformation in the whole process. And because of the impact of the landscape, we need to adapt our security posture to include virtual structures while providing a secure and survivable environment, I mean, suitable for our operations. And as we see, the traditional IT or the IT infrastructure or the service provided to the operational technology segment, usually the business owns it all. It owns all the infrastructure. And it's a high level of commitment in terms of building the infrastructure, owning and operating that set infrastructure. We have the business owns the hardware, owns the software and application development in some instances, either in-house or outsourced, and the application itself. We know that there are some pros to owning the infrastructure and being the sole owner. We get the customization is important. The control that can be exercised of the infrastructure is really important. But there are some challenges. There is a lot of costs associated with owning the infrastructure. Scalability becomes an issue because there are some logistics involved, I mean, in creating a scalable and elastic environment. The resources, because when we own infrastructure, I mean, we have to place them somewhere. We have to be aware of environmentals, and if there's any resiliency and redundancy, it's something that we ourselves produce or engineer around. Next slide, please. So even creating in a hybrid model where we have some type of virtualization, a virtual environment in a either public or private. Yeah, there is some commitment to us. There's some commitment to the business. I mean, we still own the hardware, the hypervisor. I mean, where all the virtual infrastructure will reside. There are some different ownership models. I mean, where it can be as a service. That it does reduce the operational expenses, but you still have to own some CPE, software and application development in some cases, and as a service. And there is flexibility. There is a big pro here. There is a lot of flexibility. We still retain some level of control, and ultimately, I mean, you can have, I mean, a greater degree of computer resources and on compute resources. As we go to a model where public and private cloud, I mean, merge into one, into a viable option for resiliency, redundancy, and business continuity, we will see that, yeah, there is always a challenge in terms of how we're going to secure those structures. How do we, I mean, collapse multiple security functions into a single device, either via physical or virtual, and maintain control the cost, because nobody works for free. And of course, have a larger amount of functionality that, as Chris said previously in his presentation, will protect data in motion, regardless of it being in a physical structure, being on the private cloud, or being in the public cloud. Next slide, please. What we're seeing right now, and is often unseen by OT, is that a lot of the functions that were air gap at one point, and a lot of visibility that remain behind a DMZ, now is part of a higher level ERP system. I mean, we do know that they are all that production data. It ascends from the line. It ascends from actuators, from your pump jacks, or from manufacturing environments. It ascends. I mean, either you can create a vertical model and look at it in segments as the Purdue model, but ultimately, what we see is that a lot of these platforms and all this data is moving toward an ERP system. And again, it's a shift in the industry in the fact that now data has to be immediate, has to be available for forecasting, it has to be available to the business. So we see this vertical ascent of data, and in some instances, in what we recommend, we do see a firewall of some nature in between the traditional plant, either if you follow the Purdue model, IEC 6243, and something else. I mean, that level of segmentation, there is some type of there is a firewall that divides the both. Next slide, please. In the hybrid model, the one thing that we see as an industry is the diverse and the change in methods that the user accesses the information. It used to be that we had a engineering workstation, we had a PC, we have a particular location that the users access the data to process it. Now we see by the inclusion of other devices and strategies like bring your own device, I mean, it creates I wouldn't call it much of a problem, but a concern as far as security, because now we're securing devices that typically don't conform with the security strategies and schemes that were traditionally in IP. However, we do have to provide a resilient and secure environment for all these devices as we see it. Next slide, please. So as an answer to that, to the problem of resiliency and virtualization or accessing a virtual environment, in these locations where you see a firewall, the recommendation is provide some type of remote secure line access by using multi-factor authentication. But all those devices we need to have, and one of the things that Fortinet provides is the same level of security in the virtual environment as it does in the physical environment. So the same operating system, the same capabilities exist on-prem and your traditional physical firewalls as it will exist in a hypervisor in the private cloud or in the public cloud. Next slide, please. So when we're talking public cloud, one of the trends that we see in the industry that wasn't the case as of recently is moving towards, in some instances, SCADA as a service. And what we have seen is some companies that are using the resiliency of the public cloud to not only have services on-prem, which will be a more traditional, you have a historian in on-prem, they replicate that SCADA server into a data center, a physical data center owned by the company, but they're also moving some of that functionality to the cloud. That gives it creates a lot of flexibility and efficiencies, because now, it's easier to grow a SCADA presence in the cloud than it is perhaps in the private cloud in the industry, in the data center. But the one thing that we see as a common pattern is that all this, regardless of where that server is located, the consumer of information doesn't really care. What is behind the curtain. What they want to make sure is that it's available. That's where we start. Seeing in the hybrid cloud model, where we see leveraging the compute and the elasticity of the public cloud. And also the geographical diversity of the public cloud, where now the user can be anywhere in the world, and it will access the nearest point of entry to where he's located. The other thing that we see that we can leverage from the public cloud into the private environment and create a more robust, SCADA and industrial control systems or computer management system, is utilizing a global load balancer. Fortinet, we do have a global load balancer that can, effectively join the public cloud and the private cloud. Chris also made mention of multi-factor authentication, and that is the recommended way to deploy or to protect all these diverse methods of access. Because now the multi-factor authentication client, exists on a tablet, on a PC, laptop, or a telephone. Next slide, please. As far as remote access goes, the challenge, of course, is and moving all these workloads to the cloud. As I said, is that secure access. In the past, there used to be separate components to provide an SSL front end to, let's say, for instance, create a secure session, a secure website with a web front end, a secure session from, let's say, a laptop to the public cloud or the private cloud. So by us, one of the things that we have done is include SSL VPN in all of our OS in order to provide a digital front end that can be consumed by the user, and in essence is the same in the physical and virtual environments. So leveraging the load balancing capabilities of the cloud and the load balancer that we have that efficient use of the global infrastructure, and we're pushing that towards the traditional industrial control systems that we see that we in the past were segmented by air gap, or they never had a third viable survivability option. Next slide, please. In addition to securing the data at rest, or the traditional access to data, there's also some tactics that be employed to go further down and drill down into securing the data structure. In case of OSI data, for the sake of argument, that resides or runs on SQL, we have within our OS the capability of do deep packet inspection on SQL applications, thus securing that transaction one step further. And to the user, this is totally transparent. It doesn't matter if which method they own or they decide to access. Next slide, please. So yeah, management and automation, broad protection and native integration. That is essentially the Fortinet security fabric, and for the cloud and the services capability. They are enabled for each one of those three pillars. We're investing in each one of these, to provide native integration across the cloud. So doesn't really matter if you decide to use or add Google Cloud, Microsoft Azure, Alibaba Cloud, Amazon Web Services, of Oracle Clouds into your survivability and resiliency scheme. We are developing the solution that will transcend and essentially will be the same across those environments. That dramatically reduces the time to architect the system, and it enables this protection in all the clouds. It creates a good efficiency, because it doesn't have to be done every time that you move to a new environment. The whole infrastructure needs to be revised. We can leverage the elasticity of the cloud.
Hey, thank you, Carlos. It's clear just listening to Carlos and Chris over the last 30 minutes that technology-driven change is a constant, right? It's so obvious, but adapting and being resilient requires a vision for what you're trying to do from a cybersecurity perspective. And so you take that step. One of the things that should be clear is that partnership is foundational to success. One of the things that attracted me and got me excited about what Fortinet was doing early on is they're not thinking one size fits all, but thinking about how to integrate existing capabilities using our ecosystem, a fabric connectivity, if you will, that allows engagement to happen with products you may already have as a part of your solution, because they are integrated in, designed to meet with the API and be able to provide much greater return on investment, because it doesn't require rip and replace, but rather moving forward smartly. So that whole concept then provides an agility to expand based on a fabric-based approach, an ecosystem-based approach, and that yields a heck of a lot more of agility. And a way to look at the landscape is understand there are lots of players out there. Presently we engage and partner with over 400 in our Fabric Ready Technology Alliance. This illustration says, hey, we recognize that lots of different customers are going to have lots of different situations. And so that ability to be agile, adaptive, and being able to design and think about how to solve the problem starts with understanding where you are today, then figuring out how to move forward smartly. So I might be working with designing in with a control vendor, but need to be equally competent in understanding intelligence analysis, being able to deep dive in that design we looked at earlier with the Purdue model to understand the uniqueness of what's happening in OT, and also work with GSIs because that's pulling it all together to come up with a comprehensive solution. It's clear you have to have vision. We've talked about that. And there are some keys to being successful in that space. And one is always looking ahead, understanding that the trend is going to continue, that appetite for data is certainly not going away. And so we've got ways to think about that. And one of them was clear, even as early as Chris's notion of the amalgamation of capabilities into a smaller footprint, the idea of asset identification happening within the next generation firewall, not relying on more products, but less to accomplish the same mission. Same concept here with being able to accomplish control and network access. Again, leveraging capability that you already have. In fact, a great variation on that theme is the fact that in the latest release of the next generation firewall, out just a few months ago, SD-WAN was a capability provided with that product. Not adding to the stack, but again, realizing some gain by really being able to take advantage of technology that's already present, purpose-built, designed, and also set up to operate in both standard as well as harsh environments. So you end up with a very agile solution. And then we can start to think about all of the other angles. The concept of being able to think about traffic layer 2 and below, very, very important, because now we're talking about thinking about industrial services. The backside intelligence that has to be a part of how you solve the problem, turning that whole sensing process into how you think and recognize behaviors, employing and leveraging frameworks like the MITRE framework to understand and unravel what's going on within an environment, to be able to examine and translate readiness by diffusing the attack chain. That sounds complex, but there's a way to distill it down. So we're always looking for ways to advance capabilities, even the SIM, right? And figuring out how to align it better for operational technology. Because at the end of the day, we realize that the OT client expects and absolutely has to have longevity in their solution, and it needs to fit and be sustainable in their environment. So everything we're doing is about being adaptive and resilient. With that, I think we're ready to turn it over to Cheryl Hatlevig, who will run some Q&A for us over the next few minutes.
Thanks, Rick, Carlos, and Chris for a great session. We do have a couple of questions from the audience, and I would encourage anyone that might have thought a question during a discussion to post that in the Q&A widget in the console. The first question I think is probably directed at Carlos, having just finished our discussion on cloud. OT customers are considering solutions for cloud adoption, and it's probably a new frontier for many. Are there any insights, Carlos, that you can share about how you approach that would give a greater return on investment to the customer?
Yeah, for sure. As I said during my presentation, one of the biggest hurdles in cloud adoption is uniformity of security positioning, and how can we collapse multiple functions that we see typically on the enterprise or on the physical firewall on the virtual side. It used to be back in the day, used to be that the features that you see in physical firewalls were not present on virtual devices. And that's one thing that I will recommend you do. When selecting a vendor, select one that has a uniform, a consistent operating system that not only addresses the security concerns, but it also is easy to grow and architect, and it's not a dramatic difference in between the public cloud and the private cloud. The one thing that, again, the visibility of traffic is really important, and maintaining that level of visibility and control across the three environments. And by that, I mean the physical, public cloud, and private cloud. I mean, it's important, and those are things to look for. I mean, have that level of standardization.
Thanks, Carlos. Chris, I think this question relates to some of your comments earlier. There's a lot of recognition that technology is driving how people are optimizing their industrial environments. From your experience, is there a subsector in the OT community that is in the front as having successfully addressed and implemented some of the new technologies in their environments?
Generally, I see it as being manufacturing. Manufacturing is under intense pressure to reduce cost so that they can be a low-cost leader with a high-quality product. And so there's natural pressure there for them to lead that charge. I have seen oil and gas operators or power utilities that are forward-looking, that are looking at ways to better segment their environments as well, but just not as far ahead as generally I see in the manufacturing space.
Thanks, Chris. Rick, you come from a diverse background as you spent some time at the agency. Can you give a perspective of today and the impact on OT related to cyber threats as opposed to just 5 years ago when maybe there wasn't a need to be as concerned? What have you seen as making the biggest shift?
I think, this term convergence gets thrown around a lot and sort of digital transformation, but the reality is, right, there are opportunities today for the bad actor to do things that, quite frankly, were much more difficult, expensive, certainly problematic, might have taken months or years to accomplish historically, and now it's turnkey because the opportunity is there due to the connectivity. The urgency to gain data, to be able to pivot and make smart business decisions, certainly well understood, but the proportional investment to protect those assets, which allow us to perform exceptionally in a safe and continuous way, are what's at risk right now. So I think that has to remain top of mind. I think we have to be resilient in the solution space, but I also think it requires a lot of collaboration and an ability to make sure that you tune into the unique attributes in that specific OT space. And they do vary, as we talked about earlier, from one domain to another. And I think it's important to be mindful of that as you try and solve the customer's problem.
Thanks, Rick. I think you can go on to the next slide and we can wrap up here as we just got a few minutes left before their next session.
Excellent, excellent. So, you know what, we appreciate your time today. You have our contact information, so we'd love for this to be the start of a conversation and drill much further. As we just talked about, we can concede that a lot of bad actors today are successful in targeting operational technology. I would say concede that they're already on target and start getting on with the adoption of technologies and strategy that are more proactive. We've talked about, and Chris and Carlos both shared things to look for, those adoption of techniques and strategies that allowed you to future-proof your OT security environment. I think that's very important. And in the end, it's about balancing the scorecard to outmaneuver the adversary. We have hoped we've spawned and gathered additional interest in your desire to connect beyond today. Wish you well. Enjoy the balance of the ARC event, and we thank you for your time today.